Hi everyone, and welcome back to Edge-CGI. My name is Eugene Shmirov, and in this tutorial we're going to further explore hard surface modeling techniques within ZBrush. Alright, so prior to recording this tutorial I created this really fast concept mesh with just some Dynamesh and some trim dynamic brush and some H-polish brush, just some clay tubes, all that stuff. The purpose of this model here is to kind of serve as a base on which we'll be going to be retopologizing and building on top. I kind of laid out where all the paneling will be, where I want to see it, and just kind of roughly set up the overall design. Okay, so we'll start with using Topology Brush here. Let's locate it in the brush menu, press B. Then press O to isolate some of those brushes. Locate Topology Brush. And the way it works, you create these lines, you just draw them on your mesh, and in cross sections you'll see polygons appear. Now if you want to delete some of these polys, you press down Alt and you cross the unwanted polys out, and it will delete them. So as you work with the brush, you'll see lots of these loose ends appearing, so you can delete them all together by just Alt dragging on blank part of your mesh. Also note that this brush is size dependable, so if you now click it to generate geometry, it corresponds to the thickness of the resulting geometry corresponds to the brush size. Now brush size also has an effect on snapping, and so smaller brush size will generate less snapping, and bigger brush size will make a cruder lines, but it will snap more easily to the green points in the intersections. Now the idea behind the process that let's cross these guys out real quick. The idea behind the process that we're going to be doing with this brush is that you see we have these creased edges here, like different paneling details. We basically want to lay our new topology in such a way that every crease edge, every bevel has one polygon row, one poly loop. So you can have as many as you want here, but to easily manage those later on, we kind of want to have one poly loop per bevel. Now nothing stops you from just going in here and creating several poly loops inside this, like this. You can see it works this way just fine, but it will be really hard to manage when we start creasing these angles. Alright, so this part is sped up because it's pretty boring. It's just me laying out all the topology there. As you can see, I'm kind of trying to keep the bevels one polygon width, in width. And also I'm kind of following, with the lines I'm drawing, I'm following the curves of the underlying mesh in case I want them in my final model. Now, if you don't want some of that, you can try to improvise and override some of that underlying geometry with the new one. But as you can see, the polygons that are going to be generated, as seen here with the yellow mesh, is just a preview of the polygons that are going to be generated in the end. As you can see, they kind of snap to the, well, that's the purpose of the brush itself. They snap to the geometry that's below them. So creating entirely new geometry with this is pretty impossible. But it's kind of sort of a good way, good idea to think about the later stages and to sort of try and put as much thought into this part as possible, especially if you are trying to generate some kind of geometry that's maybe going to be used in like an animation or in final rendering. Because what we're creating here, I'm still kind of trying to think about a good topology, but this the final result that I'm kind of trying to achieve is just a concept, so basically it's unimportant what kind of topology is going to be there. But good topology, deforms better, it renders better, and it's just more easily managed. All right. Here I'm kind of filling it down below. When drawing lines in the middle section, it's a good that goes right in the middle where the symmetry parts meet. It's a good idea to have symmetry on at that point, because you will be able to snap it to the dead center of your model in the axis where the symmetry is enabled. So you can still get with the symmetry off, you can still get everything transferred to the other side when you turn it on. But with creating edge loops in the middle, it's a good idea to have it on as you draw, because it will then generate less errors when and you'll see them later. Sometimes when you create this line, the line in the middle gets overlaid with its symmetrical counterpart on the other side. So with symmetry on, it will not do that. It will be a single line for both sides. But even if you generate some of those overlaps, and you'll see them kind of appearing here later in the video, there is a way of fixing those things. Alright, so now that we have topology laid out, let's decrease brush size to 0 here to generate 0 thickness mesh. Okay, so click it. Okay, let's click here. There we go. We have 2 shells now. Let's go down to Subtool Split menu and click Split to Parts. Alright, so now that we have them separate, we can start separating this guy further into different polygroups to work with, from which we'll be generating all the different panels. So we want to assign different polygroups to each panel that you kind of see here. So let's see, let's start with maybe this guy here. Let's quickly see where these guys, where this panel is. Kind of goes around here. So, well, let's use ZModeler brush for this. And in Poly Action menu, instead of QMesh, we'll select Polygroup. Single poly will define. So with Alt clicking, I want to assign this temporarily polygroup here. Okay, let's quickly see where it goes. Stops here. Okay, let's add some more here. Okay, is this where it goes? Yeah. Alright. And let's see down here below. It doesn't belong. No, wait a minute. Yeah, it'll be part of a different polygroup, so let's get rid of that with Alt clicking them again. Now that we've drawn this, we can click it, and without releasing, press Alt several times to assign a new polygroup. You can just scroll through colors here with continuously pressing Alt. Okay, so now that we have this polygroup assigned, I've noticed a kind of an error that I've been talking about earlier. We want to fuse these guys because it kind of got ripped apart. So with point action, we want to choose stitch and stitch to middle. So we click on point 1 to midpoint here. Okay, so we select to midpoint, click on first point on the second, and it stitches it. So I go through here, see what happens here. Let's stitch these guys. Alright, so let's see if we have more of these errors around our mesh here. We have one here, so let's stitch these as well. Okay. And we have, so let's go back to polygroup and let's start creating more polygroups for different parts of the model. So let's continue with this one. Okay, so this part is sped up as well. This is just me assigning different polygroups with ZModeler. You can also do that an old-fashioned way with hiding and assigning polygroup to visible, but I just kind of wanted to show different things that you can do with ZModeler here and there. So just all the polygroups are almost assigned. Now I kind of want to heal this hole here. I want to get rid of it. So let's go to ZModeler, delete these triangular polys first, and then bridge these guys across. So select Edge Action, Bridge, 2 holes, and make sure the symmetry is disabled. So let's click first edge, then the second one, and they just get bridged one by one here. Okay. We kind of need an edge loop running in the middle here. So to do that, we just click Mirror and Weld. There we go. And then we need to fuse these points together. So go to the point menu, Stitch. Instead of the previous modifier, select to endpoint. So click the first and click the one you want to stitch to. And just heal this part here. It's the same way as before. Breach some of that and weld those points. Okay. So let's continue with assigning these polygroups one by one. Handle here. Okay, so now that we have all of these guys assigned, all the different polygroups, I kind of want to sculpt a bit here with ZModeler. And what I'm going to do is I want to select hover over edge here, and I want to bridge these guys together first. So we have bridge selected. So let's bridge across here. Maybe top to bottom. No, let's bridge across. Make sure now symmetry is enabled. Okay, so click the first one, second one. Basically healing it the same way as we did before. And now let's fuse these guys. Stitch them together. Let's make sure the correct modifier is on. First point, and then get stitched to the end point. Same here. Okay, so now we have this new polygroup. Let's inset it a bit. So let's select. Let's first select this polygroup with our temporary one, QMesh. Now let's go with the inset first. Wrong modifier, inset region, and with holding down Shift, I just inset this a little bit here. Alright, so there's just some more QMeshing pushing in here. If you aren't familiar on how to work with the ZModeler brush, I strongly recommend going to Pixelogic website and checking their tutorial on this brush there, because I kind of see no point in repeating them and walking you guys through the basics of using ZModeler. Let's focus on some more interesting stuff instead. Okay, so I'm just beveling it a couple of more times. I kind of realized I needed a couple of more creases, so sped this part up as well. Just not much is happening here. Now that we have everything split and all the holes fixed, let's go to Split menu and click Split Group Split. We'll split every polygroup into a different subtool. Super easy to manage. Every polygroup is its own subtool now. And we can start paneling these guys now. Let's go to Geometry, Panel Loops menu, and just start creating panels out of that. Panel loop settings here are default, except for loops. It's set to 1 and polish set to 0. Now you just play with thickness and see what kind of thickness works. So here I'm just going through different subtools and adding thickness to them with group loops. We could have stayed within a single subtool, but I mean it's harder to manage, especially once we start creasing and hiding a lot. So it's just easier this way. Okay, so now that we have all the thicknesses set, we can start creasing these angles. And for that, we're going to be using Dynamic Subdivision, a great new feature found in Zbrush 4R7 that works really well with ZModeler and with low poly meshes. So let me press D on the keyboard here. Here you see our mesh. We can see the preview of subdivision that we're going to have once we really subdivide the mesh. Now, here in Geometry tab, there is Dynamic Subdivision subtab. Just let me find it real quick. Okay, Geometry, Dynamic Subdivision, there it is. So you can see it is pressed. If we unpress it now, you can see we have our low poly mesh. So you can use D and Shift D on your keyboard to drop in and out of Dynamic Subdivision here and see all the low poly changes on subdivided mesh. We can still go here and mess with this settings increase menu, but there's a lot of guesswork with this and I want to have more manual control. Now before starting manually creasing some of these guys, we might still want to go to crease menu and press crease polygroup border there, crease PG. Yeah, press it. You see polygroups, their borders, as the name implies, get creased automatically. Okay, now let's go into ZModeler Edge Action, select crease here and Edge Loop Complete, and just click on the edge loop that you want creased. And in DynamicSubdiv, you'll see the changes happen instantaneously. Since these panels are two-sided, we want our creases to be exactly the same on both sides to avoid errors on the polygroup that is kind of in between them. So if you don't want any edge stretchings, you better keep track of your creases on both sides. This is why we're using Edge Loop Complete for some of these longer creases, and then I switched it to just Edge crease in ZModeler menu targets, and now I'm just manually creasing some of these edges in between here. Alright, so let's crease some of these guys here. As you can see, I'm dropping in and out of the Dynamic Subdivision to see which edges are creased and which are not. You can also preview it by just paying attention to the lines on the edges. Now the dotted line represents a creased edge, but with the edges this small, it's sometimes hard to tell. The cool part is we can click on different subtools here and kind of see how they match together. So let's start creasing all these other guys. Now this part is sped up as well because it's kind of dull and boring. But basically I'm just repeating what I've been doing before, creasing these edges, going in and out of Dynamic Subdivision. Cool part about Dynamic Subdivision, note that, first of all, note that Dynamic Subdivision is not the same as subdividing your model. It's just a preview. And if you have any experience of working with conventional 3D applications such as Maya, you'll know that Maya has a system like this as well. Where you can basically preview your sub-D model but still kind of retain the control of low poly cache. You can crease edges and add more edge loops to kind of control the subdivided result here. Once we're happy with the result of Dynamic Subdivision, we can click Apply button and get several subdivision levels out of that. That will look exactly the same as they looked in Dynamic Subdivision mode. You can, of course, you can subdivide manually and go back and forth between subdivision levels, but when creasing, this can lead to destructive results, especially if you, like, on a higher subdivision level, for example, you uncreased some edges and then you go back several subdivision levels. It can destroy the outline of your model, so you have to be careful with that. Now, Dynamic Subdivision allows not to encounter this kind of problem, because it's not really subdividing anything. And but be sure not to use Dynamic Subdivision levels on the model that has more polygons, because it's really going to slow down your machine and even lead to some crashes. Throughout the recording of this tutorial, I had it crash for several times, so there are some like really noticeable cuts in there. Okay, so here I'm just creasing all of the parts, basically as before, following the concept mesh that we had. Still using the dynamic subdivision. Note those pins that kind of stick out of your model. Those represent the underlying low polygon cage, to kind of make it easier for you to see where original edges were and where they're going to be once subdivided. But sometimes it kind of requires you to drop out of DynamicSubdiv mode, because it sometimes is hard to target some of those edges, and because when you're in DynamicSubdiv mode and you want to target a certain edge, for example, or point, you have to actually target it as if it was a low poly mesh. Alright, so once we've done creasing everything here, we can start detailing. Let's create a nozzle here. I'm going to append a cylinder real quick, put it in place here with the good old trustworthy transpose line. Just move it around here, rotate, scale it down a bit. Alright, just a bit more. Okay, let's place it in there, see how it fits. Might be a bit too big. I'll fix it later. So let's isolate that. And since it's pretty low poly, we can use ZModeler for this as well. So let's Q-mesh some of this. Select polyloop and start creating some more interesting shapes instead of just a cylinder. Maybe some kind of I don't know what these are, maybe some kind of heat reduction things. So as you can see, I'm just like doing some basic Q-meshing here and there. Flat border will work for this, so let's inset this guy in. Okay. Still not working. Okay, inset region. Okay, so let's make a cylinder out of this guy. Q-mesh it in here. In case you wonder and don't really want to go to the Pixologic website, the menu is opened with pressing down and holding spacebar. Okay, so let's Q-mesh some of these guys in here. Alright, let's speed this part up. It will take a while. There's basically nothing interesting is happening, just some Q-meshing and just pushing through. So here I kind of realized this was too big, so I just made it smaller and created just a copy of this. Several copies. Maybe it's kind of peculiar gun. Okay, so now I'm just sort of trying to figure out where the trigger hole is going to be. Just good old creasing here as well. And here I just grab my ZModeler, still in DynamicSubdiv, so no real subdivision levels, and I'm just adding some details here and there with basic, ZModeler workflow. Just kind of trying to think about what this handle is going to be. At some point, I realized that Move Brush is just going to work better with this. Just to achieve like the shape a real gun handle would have. Just here I'm just kind of extruding some of these polys to create maybe some kind of suggest that this is mounted on the detail beneath it. As you know, in general, guns, if you look at the reference online, have this sort of modular design approach. You can assemble and disassemble them. And this is what I'm kind of trying to maybe, to kind of sort of have this look here, since despite being sci-fi, this is still a gun. And from design standpoint, if you kind of follow the basic design rules found in real manufactured guns, you can imply that this gun is like a man-made thing, and maybe it's not, it's not alien. It's kind of down to earth, because it kind of follows the basic rules that we have here on Earth of manufacturing things. Just a quick design tip here. Okay, so here's the trigger. Just appended new subtool and just worked a bit more with ZModeler here, and move brush to just kind of. Okay, so we're almost there. So at this point, I jump in and start using IMM brushes that kind of go with just ship with ZBrush. Industrial parts brushes for some bolts, modeling toolkit for some panels and kind of interesting shapes that I can put here and there. Okay, so just some buttons, some secondary details, anything that can suggest the high-tech, sci-fi quality of this object. And so I go through with creating some more secondary shapes, maybe some protruding like cylinders here and there. Maybe these are some kind of indicators on how many bullets you have left. Here I grab some of the custom brushes. In case you're wondering, be sure to check out my previous tutorial on the channel where I describe how to create these brushes without needing to use Photoshop or any external application. Right within ZBrush you can create these guys. So basically, at this point, you're just breaking the monotony, creating some visual noise, applying some paneling, applying some technology in there. We're almost there. Just a couple of touches, a couple of like circular insets here and there. Okay, so I'm just looking over here and just seeing which parts of the gun are not detailed enough, and just insert some details in there. More visual noise, maybe some more indicators here. Okay, so our gun is finished now. I kind of went ahead and, as usual, rendered it out in Keyshot and did some quick Photoshop compositing. If you're curious about that, be sure to check some of my other videos on the channel that cover both Keyshot rendering and Photoshop compositing. I hope you found this tutorial informative, and if you did, don't forget to share, like, and subscribe. And thanks for watching Edge-CGI. I hope to see you soon. Bye!